Hello. Let's try to highlight the way we can apply the formula we have derived regarding the acceleration of gravity on the surface of any planet. Let's start with the first example. The first example has to do with comparing the gravitational acceleration on the surfaces of two different planets. For example, let's say that we have an unknown planet having a mass which is given to be 4 times the mass of the Earth. And the radius of this planet is, let's say, 6 times the radius of the Earth. Let's try to find out what is the ratio between g on this planet over the g on the Earth. We're talking about the surface of both planets. Otherwise, we can also apply the same method, but we need to know the altitude, the height measured from the surface of the planet in order to apply the same formula. Let's go. So g of the planet over g of the Earth would be g, the gravitational constant, times the mass of the planet over the squared radius, and the same for the Earth. The constant is cancelled, and we have the ratio of the masses multiplied by the inverse squared ratio. Pay attention at this point. You know the rearrangement of these terms. Sometimes we can make mistakes. So we have mp over me multiplied by the square ratio of re over rp. And now we have to plug in the numbers we're given. This is 4 times mass of the Earth over mass of the Earth. And this is r of the Earth over 6 times the mass of the Earth. These terms are cancelled, and we have 4 times 1 over 36. And we can finally write it 1 over 9. So it's obvious that g on this planet should be 1 over 9 times g of the Earth, and any mass located at the surface of this planet would have a weight, WP, 1 over 9, W is the weight, times, the weight of the Earth, on the Earth. Now, this is the first example. Let's go to discuss about the second one. The second one has to do with something different. We have already tried to highlight it, but it's a good idea to replay it, to review it. So let's take planet of any radius r, like this, and a certain mass m. We have the radius and the mass. And we want to go out there at the position P, and generally talking, the height measured from the surface of the planet is usually given in terms of the radius. For example, let's say that h is 4 times the radius. Okay? Don't forget to be sure if the given data, the distance, is the distance measured from the surface or from the center. Pay attention at the wording. Read it word by word and make sure, confirm that you know what the distance is about. I repeat it, from the surface or from the center. And now, suppose that the problem says determine g at this height, at this position P, g, P, in terms of GO, where GO stands for the acceleration of gravity on the surface of this planet. It's what we say on the Earth to be equal to 9.8, but just for the Earth. For another planet, it may have a different value. So generally talking, we are supposed to be given this magnitude. So let's go. G m over, look, this is the distance we call r when it comes to gravitational law. So we have to start with writing g times m over r squared. And now we can write r plus the altitude squared, which gives r plus 4 times r squared, and it comes to g times m. This is 5 times r squared gives 25 times r squared. And now you can see that GO on the surface would obviously be g times m over r squared. And if you compare this one with this one, if you find the ratio, it's obvious that g is just GO divided by 25. And in this way, no matter what the distance is, we can find the acceleration of gravity of any planet at any position if we are given the acceleration of gravity on the surface of this planet. I think it's simple. Try to study it again. I think that both of these examples are very useful in order to have a deeper understanding of what we call gravitational acceleration. Thank you.